The length of 40 leaves of a plant are measured to 1 millimeter, and the obtained data is represented in the following table. So we have leaves measuring from 118 millimeter to 180 millimeter. Draw a histogram to represent the given data. Hint: first make the class interval continuous. Is there any other suitable graph representing for the same thing? And okay, second and third we'll answer later. So first thing is, it's about histogram. So whenever you come across a histogram question, my request is please see to that you have a checklist. The checklist being, is the class continuous? Well, let's see. We have to look at the lower limit and the upper limit. So that's your upper limit and the other one is the lower limit. 126 and 127, no, it is not continuous. So we have to make it continuous. Very simple. All we have to do is add and subtract with a particular number. And which is that number? For that we need to do a calculation over here. X is equal to subtract one of the upper limit and the lower limit in the previous class. Sorry, it's the other way around. Lower limit minus the upper limit in the previous class. Difference is 1 and the answer is half. So we need to add to upper limit. Okay, so to do, we have add half to the upper limit and lower limit you need to subtract. So basically this will be 17.5. Next one is 126.5, 135.5, 144.5, 153.5, 162.5 and 171.5. Then put hyphens, and if you have done the right thing over here, you just have to copy. Okay, so let me just verify this once more. Okay, reduced by 1. Okay, right and right. Yeah, now we just have to copy this, and that's how it becomes continuous, right? That's the whole idea. We're just adding equivalent to just copying from the next one. And this is 180.5. Remember, we need to add, and then we have the frequency. So this is 3, 5, 9, 12, 5, 4, 2. And class width, just for the sake of checking, right? Next thing is, so we converted, this was not continuous, so we converted it. Next is class width is same. We have to check this actually. So here the difference is 9, 9 again, 9 again, 9, 9, 9 and 9. Okay, class width is same, so we need not convert this. Okay, so this is not required, right? So I have the right things. Now all I have to do is plot it. That's it. And we have our x and y axis. That's my x and that's my y. Actually it's the other way around, my bad. Okay, now decide on the scale. So we started with 117.5 and 108.5. So we need to use a kink that is there, and we can start off with 117.5. So how many are there? 3, 6, 7. So every 2 centimeter we can, 126.5, you can do this. And this will be 135.5. We just need to add 9, right? I mean, we saw that. 153.5, 162.5, 171.5 and 180.5. Is this correct? 180.5, last one, yes. And here the maximum value is 12 and the minimum value is 2. So we have 0, 2, 4, 6, 8, 10, 12 and 14. Okay, so yes, we have the required graph, and all we need to do is plot it. So let me just take it a bit up. It's convenient. What did I do? Nothing. Okay, it's set. Okay, that's what happened. Yeah, now we are set. So first one is, I will get confused with this actually. Let me cancel this. And we have 3. First is 3. So we have between 2 and 4 is 3. And the class size is 2 over here. Then it's 5. So between 4 and 6 is 5. And then 9. And that's 9. And then 12. And then 5. And then 4. And then 2. Okay, so this is our output. This is 10, 6, no, wait, 6, 8, 10. Looks better, right? So not the complete thing, we need to label and everything. So this is to do with length in millimeter. This is to do with number of leaves. And this is to do with scale along the x-axis. For every centimeter, we have length for every centimeter is 0.45 millimeter, right? Because this I've taken the difference as 9. Between 2 centimeter it's 9. Oh yeah, sorry, not 4.5, not 4.5 millimeter. And y-axis we have every centimeter is 2 leaves. My bad. So this is 4.5 millimeter. Because the entire length is 2 centimeters of gap of 9 units, 9 millimeter. So 1 centimeter is 4.5 millimeter. Again, it's left to you guys how you want to do all of this graph. So for this, this is convenient. You know, the width is fixed and everything. Okay, so this is your answer. It's a bit congested. Okay, I hope this makes it a bit less congested. Right, so this checklist is something that you guys can't miss. That is must to have. And writing the scale and the title and the number of leaves and the measurements along the x and y axis, what kind of things we are putting across, that also has to be mentioned. That is, label your x and y axis. So don't forget all of those, right? Then we have, is there any other suitable graph representing for the same data? Yes, since it's continuous, this one, you can represent it with the help of frequency polygon. So the answer for the second question is frequency polygon. And the third is it correct to conclude that a maximum number of leaves are 153 millimeter long, and why? Well, we can't definitely tell it's 153. Yes, it is, the maximum number of leaves are between this range, but not exactly 153. We can tell as that we can't actually tell that the maximum number of leaves are 153 long. We can tell no as the data is a group data. Not ungrouped. So we cannot, thus we cannot, we can, 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 we definitely, or we cannot specify give a specific measurement. We cannot give no, that's enough actually, as the data is not grouped, so we cannot answer it. That's it. We cannot talk about a specific data actually. Yeah, that's what I wanted, right? We cannot talk about a specific value. Thus we cannot talk about a specific value. Thus we cannot talk about a specific value. So if they asked for a range, then we could have told, but they were asking for a specific value, so we can't answer that. That's not possible, right? It's like half information, so we cannot answer this question. So we are done with this. Is there any other suitable? Yes, we answered that also. Very important, the checklist and the conversion drawing part, though you guys do it. That's not, I'm not worried about this actually. I'm worried about you guys missing out. Actually, yeah, you guys will miss this also, scale and everything. Okay, overall, there are quite a few things that we need to keep in mind, that what is possible, that this x-axis 1 centimeter can be taken as 4.5 millimeter. All that is okay. You know, the gap is 9. You guys need not be scared that should I take 9. Need not. You can represent whatever you guys want to. You just have to mention that. So let's do this on the simulation, and here you can see that I'll give a class size of 9. Right, we took the class size of 9. See, we have the same answer. So let me show it to you guys properly. Right, we have the same answer. Okay, so with 9 you can see even over here we are able to get a proper beautiful answer over here, properly shaped, and obviously it's simulated, so it will be proper, good looking. Right, so don't miss any of these points. Please see to that you understand the idea about taking scale. That's where you will mess up, and this is something that checklist is something which you guys have to learn, and hopefully all of this adding to upper limit and subtracting from the lower limit, you guys have to understand. So what is upper limit, what is lower limit, all these basic things. These are small things that you can miss and get the answer wrong. If not, there's nothing much to this. So this is your answer.